Hello everybody, my name is Thomas W. Timbrooks and I'm running for the United States House of Representatives for Oregon's 6th Congressional District. My motto is I want to make Oregon's 6th Congressional District America's greatest congressional district, and I want to do that by making Oregon a place where cancer comes to die. Okay, so today on this installment of my little show, here's the thing. I make these little videos here. Egyptian licorice tea, very good stuff, man. It's really, really good. Trust me on this. Go to the store, get yourself some Egyptian licorice tea. You will not regret it. So I make these little programs. I make them on YouTube because YouTube is free, and I've got a budget of $0 for my campaign. Experts have told me you got to spend at least $3 million to get the seat in Congress. I don't want to spend $3 million to get the seat in Congress. Trust me. If I had $3 million, I'd probably buy a Winnebago and just start traveling across the country and just forget everything. I would just give up. I'd wait for the zombie apocalypse to happen, you know. I'd have a whole bunch of chili and just camp out. Camp out while the zombie apocalypse takes over the planet or something, man. Yeah, if I had $3 million, I wouldn't waste it on a campaign. I don't think campaigns should cost any money. I don't think they should cost $3 million. And that's why most people don't really have much interest in politics, is because in order to get into politics, you have to have a whole bunch of money, and I think that's just wrong. If I do get to Congress, I think that's something that I will address. So anyways, with today's thing, I wanted to, okay, my core values: limited government, local decision-making, free market economy, fiscal responsibility, personal liability and responsibility. Those are core values of conservative Republicans. And insanity is a mental condition that prevents a person from fully understanding the consequences of an action and distinguishing right from wrong. Both those criteria have to be met in order for a person to be insane. And the reason I say that is because politicians keep on saying that the definition of insanity is doing the same thing over and over again and expecting different results. Well, I call BS on that. That is official. You can go tell your neighbors and your friends that is not the definition of insanity. The definition of insanity is what I just told you the definition of insanity is, okay? So both those criteria have to be met, all right? So now you can tell your friends. So today I want to talk about something that does not directly affect Oregon, but indirectly can affect Oregon. And by fixing this situation, Oregon can benefit directly. And lots of good stuff can happen for Oregon if we do it this way. Okay, so listen to what I have to say, and Oregon could potentially benefit a great deal on the plan that I have. And what I have right here: American Resource Recovery and Energy Optimization Initiative, a national strategy for jobs, energy, and long-term resource preservation. Boy, the left side of that thing sure looks a lot darker than the right side. But hey, you know, this is, I had these slides generated from computer generated, because I also cannot afford photography. I can't afford to have a person make these slides for me. I'm kind of well, I'm not poor, but I'm not rich. Okay, America faces a unique challenge. Valuable energy resources are being lost while opportunities for job creation remain underutilized. Coal mine fires burn resources, communities pay the price. And you see that there, that's like Centralia over there in Pennsylvania. That's that ghost town that's created because of the coal mine fire. And yeah, this presentation is going to be about coal mine fires and how opportunities are being lost because of them. Coal mine fires and inefficient combustion systems represent loss of energy. Billions of BTUs, British thermal units of heat and resources, go to waste. Environmental damage, toxic emissions, polluted air and water, and degraded land. Missed economic opportunity, jobs aren't created, communities left behind, and economic potential is lost. And here's what's going on there. See, coal mine fires, there are coal mine fires all over the place. China has a coal mine fire that's been going on for like 300 or 400 years. In Germany, well, not in Germany, in Europe. In Europe, there is a coal mine fire that's been going on for like 200 or 300 years. In America, our oldest coal mine fire is, I think it's the one in Centralia or whatever. That thing has been burning since the early 1960s. Okay. The reason we aren't putting these coal mine fires out is because it costs a lot of money to put out these coal mine fires, okay? And the coal is not valuable enough to recuperate the loss. So if it takes, let's say, $5 million to put out a coal mine fire, the coal you get out of that mine might only be $1.5 million, maybe $2 million. So you're spending more money than you get back. So you see, this is where the government has to come in and take care of things. The government is really good at spending money and getting a diminished return. But this is where we have the last part of the preamble to the Constitution is secure the blessings of liberty to ourselves and our posterity. So for the children and the children of children, people who are going to be around 50, 60, 100 years from now, they are going to need the coal. The coal that's burning right now, it's incinerating right now and won't be of use anymore in the future. That coal has to be saved for them. And the government has to come in and put out those coal mine fires so that we can use that coal in the future. Okay, that's the idea. That's the whole reason I'm doing this now, is because I am worried about the future for America if all of the coal that is in these coal mine fires, I think there's 625 coal mine fires across the United States. 625 coal mine fires across the United States. That's a lot of coal mine fires. That's a lot of coal that's just being burnt up, okay? If we can put those coal mine fires out, then we can reap the benefits of that coal. But right now, it's just burning up and it's destroying America's future. Because America's future will require electricity that is more than likely going to depend on these coal-burning power plants. Okay, so that's where we're going there. The proposal here, coal mine fire extinguishment and oxygen-based combustion optimization. That's part 2. See, I'm going to get to that later. Safety detect, contain, and extinguish underground coal mine fires. Stop subsurface fires, save land and resources, protect communities and the environment with the oxygen-based combustion optimization. Enhance combustion efficiency using oxygen-enriched systems, increase energy output, reduce emissions, and improve efficiency and reliability. Turning energy loss into national strength. Okay, our guiding principle, public investment should advance the goals of our nation and set forth the U.S., as set forth in the U.S. Constitution. That's why I said in the preamble, you've got promote the general welfare, secure the resources for future generations. And that's kind of an important thing for future generations, you know. Grounded in the preamble to the United States Constitution, promote the general welfare, secure the blessings of liberty. Saving the coal mines from being on fire and everything, that's a very good thing. It it satisfies the whole Constitution and everything. And it's a good thing to make the Constitution. In America, we want our Constitution to be a happy Constitution, and the way to make the Constitution a happy Constitution is if you don't defy its principles. Okay, and so in this way, the founding principles of the United States are that all people are entitled to life, liberty, and pursuit of happiness. This is part of it. The pursuit of happiness is, making sure that in 100 years, 200 years, people who need electricity are going to be able to get it. Okay, so that's one of the founding principles of America. Okay, so core objective here, transform energy loss into job creation, technological leadership, and resource preservation. Okay, so technology track number 1, subsurface thermal containment. Detect, contain, extinguish, protect communities, preserve resources. And what you got there is, this is the coal mine fire, active coal mine fire that's going on underneath the ground. The key benefits are protect communities, preserve resources, reduce costs, and deliver lasting results. We're going to detect the fire, isolate the fire, inject specialized agents and that are injected to create a thermal barrier and extinguish heat and oxygen, are removed, fire is suppressed. Yeah, heat and oxygen are removed, fire is suppressed. Okay, so you take away the heat, you take away the oxygen, boom, you got no fire. Okay. Stabilize the area in a cooled, sealed, and monitored. Okay, so there you go. Okay, the problem here is the coal mine fires burn for decades or centuries, destroying valuable resources. We just said that. Destroy resources, environmental damage, economic devastation, persistent and expensive. And this happens, you got an abandoned town with no future. And you got the invisible energy, which is underground and out of sight. Fires spread silently, making detection and control extremely difficult and expensive. And this is where we get, all the kinds of chemicals and everything in the groundwater. The groundwater is contaminated. You can't live there. The fires underneath the ground, they cause the earth to open up and all kinds of bad stuff to happen. Carbon dioxide flows out and it kills people. It's not a good thing. It's just not a good thing. So you want your coal mine fires to be put out as soon as possible. It's just generally not a good thing to have coal mine fires. There's too much damage that happens with it. And they don't go out on their own. Okay, so yeah, we've got many coal mine fires. Like I said, about 625. The Centralia mine fire, burning since 1962 with no economic return. Centralia is there in the middle of Pennsylvania, which is coal country. There's a lot of coal. I mean, that Centralia fire, they say, could burn for the next 200, 300 years. That is a lot of coal that's burning up that future generations could potentially need. And so, the cost of inaction is no economic return, lost resources, ongoing environmental damage, and just a general burden. The town is lost, and powerful reminder, when we fail to act, we lose resources, communities, and opportunities forever. So, yeah, let's fix this. So here we have the fire triangle. Now every fire requires heat, fuel, and oxygen. Okay, now what's going on in here? You got these fires underground. The oxygen actually comes from the coal. As soon as the coal burns, there's some oxygen in there. So it's one of those self-sustaining fires. So the coal is the fuel, and the oxygen comes from ground moisture, water, whatever. So you have the oxygen and the fuel. What we need to do is remove the heat, and that's the idea that I have going on. I want to talk about me being an engineer, how I'm going to handle doing this fire. What you see right here, okay, this is how an air conditioner works, okay? Air conditioner. If you ever take one of those cans of dust off, you just pss, 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 that guy right there, pss. If you do the dust off thing for a long time, you pull that trigger, it pss, keeps on letting it out, and then you notice the can gets cold, right? The can gets cold, and you get frost, and it freezes, right? See, this is a principle of thermodynamics, and this is how your air conditioner works. Whenever you pressurize a gas, you pressurize it to, let's say, 2 atmospheres, okay? So if I take all this gas right here and I pressurize it down to here, okay, it's going to double the pressure. The temperature is going to go up because the atoms are hitting each other a lot. There's a lot more friction. The more I pressurize it, the hotter it becomes. So if I pressurize, let's say I pressurize this much air down to this size, it's going to be very hot. So I'm going to dip it into my tea here, and it's going to cool down. Okay, so all of the energy that's in there is lost. And then when I release it, I just let it just go like this. It's going to look for that same energy. All the energy that it lost, all the heat energy, the thermal energy that this gas lost, it's going to absorb that energy from the environment. Okay, and that's how your air conditioner works. You have an air conditioner compressor, and it compresses Freon. The Freon gets very, very hot in the little tubes and everything. And so those tubes full of Freon are cooled down by air or water or whatever, just some kind of cooling media. And this is where, the outside of your home, you got that fan, you got the big box and you got the fan, and the fan circulates air, and the air circulates over all these tubes that are full of the compressed Freon. So the Freon goes in really hot, because it's compressed, and then it cools down and cools down and keeps on, and it gets to about room temperature, and then it goes back up to the air conditioner where it decompresses. And when it decompresses, that's where it takes all the heat. It takes in all the heat from your house. So you've got a fan up here that blows the air in your house across this coil that is absorbing heat. And the Freon absorbs the heat that's in the air that's in your house, and it takes that heat outside to the compressor that's outside, and it goes through the process all over again, okay? So here's the idea that I've got for the coal mine fires. What we're going to do is we're going to take these drilling pipes, and we're going to drill down to wherever close to the fire. We're not going to drill down into the fire, okay? That would melt the pipes. We don't want to do that, okay? So we're going to drill down close to the fire. It's going to be very, very close to the fire to where the ground is elevated in temperature. And then we're going to take these pipes and we're going to compress them a lot, maybe 50,000, 100,000 PSI. As soon as those pipes have absorbed all of the heat that's in the ground all around them, boom, we just let the atmosphere out and it goes back to atmosphere. Okay, all of the heat that was in those pipes, all of the heat that is in the ground that is surrounding these pipes has been removed and brought up out into the gas. So if essentially what we're going to do is we're going to turn the ground into a block of ice. And once we've got that ground turned into a block of ice, then we're going to drill a little bit closer, turn that ground into a block of ice, drill a little bit closer, and we're going to systematically get closer and closer and closer to the fire. And every time we get closer to the fire, we're going to turn the ground into a block of ice. And as we turn the ground into ice, that's when the fire is going to go out. So basically we'll go in waves closer and closer to the fire. We'll surround the fire, and ultimately the fire will go out because the heat will be removed. And that's how the fire triangle, it'll have plenty of fuel and plenty of oxygen, but it will not have heat. If you remove the heat, you remove the fire. The fire goes away. So that's how I want to take care of these coal mine fires, is by removing the heat. And once you remove the heat, you remove the oxygen, because like I said, the fires are self-sustaining because they are so hot that they actually cause the groundwater to split up into oxygen and hydrogen. And when it splits up, then the coal mine, the fire in the coal mine, is just going to use that oxygen to sustain the fire. So once we remove the heat, well, then you remove the heat and it won't be able to make oxygen anymore, and so the fire will go out. And that's how we're going to take care of that. Okay, whoops, a little bit. Engineering method, and you can see right here we've got a drill going down, and that drill is going to go down fire zone access and treatment delivery. Okay, so Oh, it says right here, inject suppressing agents, inert gases or thermal barriers to extinguish and contain the fire. That is how they do it now. And I could not find anything. See, what I'm talking about doing is, it's kind of a revolutionary concept. It's a different concept. And it doesn't actually inject any chemicals into the ground. It just freezes the ground. And I think my way is a better way to do it because, like I said, it doesn't inject any kind of chemicals into the ground that might end up in the drinking water. So we do it my way. We freeze the ground, turn the ground into a big block of ice, and then we'll work on that later, okay? So the cooling system concept, like I said, install the closed loop heat extraction system underground, and this is where we compress the air, and then after it's compressed, we release it. We allow the heat to be drawn out of the ground, and as the heat is drawn out of the ground, the ground cools, and as the ground cools, the oxygen goes away, the heat goes away, the fire will eventually go away. So that's just basically, heat removal. Circulating gas absorbs heat from the surrounding rock and coal. And this is essentially, like I said, this is how your home air conditioner works, except it's not going to be cooling you off, it's going to be cooling off the ground, which will save us a whole bunch of coal. It's going to cost a lot of money. It really will. It'll cost a lot of money. It'll cost more money than we will recuperate, but really that's what the government is for. The government is there to spend money where the individual can't really spend money. Okay, because I mean, let's say going into outer space. We recently just sent people back to the moon. Why? Why did we do that? Well, we've got a space program, and if we don't use our space program, okay, to not use something is to admit that it has no purpose. Okay, so we have a space program. Why aren't we using our space program? I guess because it has no purpose. No, it has a purpose. We're going to fly people to the moon. Okay, why? Because moon people. I don't know. The space program is an important scientific program. It's very important scientifically because there are a lot of things involved in the space program that actually stimulate technologies here on Earth that we don't know about. We seriously don't know what kinds of things what kind of technologies can be stimulated here on Earth by the space program. But we do know that some technologies can be. The space program is a very important thing for many levels, but I digress from talking about the space program. This program right here is going to cost more money than it will return, but you see, the whole idea here is we want to save as much coal as we possibly can, because future generations will need that coal. And we're talking about people 100, 200, maybe 300 years from now will need that coal. Okay, we can't use just nuclear power, because here's the thing about nuclear power. There is a finite amount of uranium on the planet, and scientists estimate the amount of uranium on the planet if it is used. If we 100%, if we use all of the uranium on the planet for electricity, we will still need coal-fired power plants. Okay, so we will need coal-fired power plants in the future. We're going to need it for ships, for trains, for heat, for electricity, just for everything. So in the future, we will need coal. So it's very important that we save our resources today that we will need in the future. Now, I'm also leading to a different form of power production. So that's going to be next here. Okay. Okay. So oxygen reduction. Like I said, you got seal the oxygen pathways using grouting and containment techniques, and that's all because the ground is very porous, and things are going to happen at high pressures like that you don't count on. But the important thing is, let's get these coal mine fires out. The combined effect, cooling plus oxygen reduction, is going to lead to fire extinction. Okay, so we're going to get rid of the fire. And monitoring systems are going to make sure that the fire stays out. Once we get the fire out, it's going to stay out. And the outcome is the fire extinguished or contained through engineering solutions and continuous monitoring. Underground coal fires are brought under control for a safer, more sustainable future. So we're going to save our coal. Now, the secondary benefit, land becomes stable and reclaimable, which we want. Stable and reclaimable land. It's a good thing to have stable and reclaimable land. By extinguishing underground fires and stabilizing the subsurface, the land is transformed from a liability into a long-term asset for communities and environments. Okay, so this is a good thing that we get rid of the coal mine fires so that we can have useful land again. Resource recovery. The previously lost coal becomes accessible. So once we get those fires out, we can start mining the coal once again. Okay, so that's kind of an important thing there. All right. Now, the energy recovery opportunities. Heat removed from the fires can be used productively. We can use that heat to generate electricity and so forth. So. Yeah. Economic transformation, convert a liability into an asset with underground coal fires. Okay. Job creation, track one, so for drilling crews, engineers, and equipment operators. So this is a way to provide jobs for Pennsylvania. And this is one of the things that people do in Congress. You see, we're going to help put out these coal mine fires in Pennsylvania, Kentucky, Tennessee, all along the Appalachian area. The Appalachian area is where there's a whole bunch of coal. There's coal. There's other places in the United States that has coal, but I mean, those are the major places right there. Those are the places that we're looking at that we can get the coal, but. Helping, if we in Oregon, as a politician, let's say I'm over there, talk to the people in Appalachia and say, look, you guys need to put your coal mine fires out. You're going to need our votes in order to do it. So you'll get our votes in order to do it, but we're going to need your votes on something else. And I'm going to get to that in a minute with this. So we'll get jobs over there where they need jobs. Technology track number 2, advanced air separation and combustion optimization. Now, this is the part that I want to talk about. It leverages cutting-edge technology to improve fire control efficiency and reduce environmental impact and drive down operating costs. Advanced air separation, combustion optimization, real-time monitoring and control, and environmental protection, and continuous innovation. Here's where I need to start explaining to you, okay? Now, about 10, 15, I think it's been about 20 years. Okay, but yeah, I think it was back in 2005, 2004, something like that. My mom, living in Arizona, and she started having problems with her lungs, okay? That's because they got dust and dirt and everything over there in Arizona, and a lot of pollution. It's Phoenix is the Valley of the Sun. They got a lot of pollution there and everything. It used to be the place if you had some kind of problems with your lungs, you'd go to the Phoenix area because the air was dry and it was warm. It was a very hot, very dry place, and apparently that was good for tuberculosis. Okay, if you had tuberculosis or other problems with your lungs, you'd go out to Arizona and that air would fix it somehow. I'm not exactly sure. I wasn't around back then, but yeah, that's why my mom's family moved out to Arizona, because apparently her father, my grandfather, had some problems with his lungs. Well, now you've got a whole bunch of dust and pollution, and it's just a disgusting place to live. I would never move back to Phoenix, Arizona. There's other places in Arizona that are absolutely beautiful. I would live there in a heartbeat. But yeah, not around the Phoenix area. There's too much pollution. So anyways, I noticed my mom was carrying around this tank. And I thought, well, is that an oxygen tank? And she said, well, it's an oxygen separator. Oxygen separator. And I didn't know what the difference was. I didn't ask too many questions. Well, I went online and I did some investigation for these oxygen separators, okay? Here's the mechanics. You take this mineral substance called zeolite. And zeolite is a volcanic ash related mineral. It is a mineral that exists in places where there's volcanic ash, like the northwestern United States, Oregon, Washington, around Idaho, around this area. So we have lots of zeolite here. And what zeolite does at a microscopic level, it's porous in a specific way. If you take regular air, you have a big tank like this, well, it's just your thing like my mom used to drag around. You have a tank in there, and this tank compresses the air. And as the air compresses, the porous nature of the zeolite causes the nitrogen to absorb. So the nitrogen goes into the rock, into the zeolite, and that leaves the oxygen outside. Okay, so the nitrogen is pushed into the zeolite, the oxygen stays out of the zeolite. Okay, so outside of the zeolite, you've got pure oxygen. Well, the machine, the mechanism, it extracts the oxygen from the air that is, just as it's compressing. Okay, so what this zeolite oxygen this air separator mechanism does is it removes oxygen from the atmosphere and it leaves the nitrogen. So the end result, the air goes into the machine, oxygen comes out of the machine. Okay, basically that's it. It's an air, there's a company called AirSep, and they make these devices that, things to carry with, and they also make oxygen separators for hospitals and for mines. If you ever worked in like a gold mine or a coal mine or something like that, oxygen is blown into the mine, and it is provided by one of these air separating devices. So this is your oxygen supply. Okay, so my way of thinking, because I'm an engineer, is if you took this little device that takes air and it brings air in and it shoots oxygen out, I was thinking if you were to feed this oxygen line into just an internal combustion engine, just a regular gasoline engine, you could probably improve your performance a lot. And with a much, much bigger device, if you had something that's the size of your living room or maybe a small house, you could remove a whole bunch of oxygen from the atmosphere. And that oxygen, if you fed that oxygen into a power plant, the actual ignition, if you have fuel, you have your fuel here, you have oxygen blowing in, and what they do now is they just take air and they supercharge the air, they blow the air in, so you get a lot of more oxygen in, and that's how like with blacksmiths with their thing, they would make the fire hotter. And that's what happens when you blow on a fire and it glows red. Okay, you are increasing the amount of oxygen that the fire is exposed to. That's how that works, all right? Well, If you have an oxygen separation device and that is feeding oxygen directly into a combustion chamber where you put your coal or your liquid gas or whatever you're burning, whatever it is you're burning to create the heat that produces electricity, the extra oxygen, it helps your efficiency. It helps the efficiency of your electrical production system. Okay, and so that's from that idea, that's where I started out. That's the kind of thing that I want Oregon to get involved with, because you see, Oregon and Washington have a whole bunch of this zeolite. Okay, this is where zeolite is located at. We've got the volcanoes with volcanic ash. That's where the zeolite is at. We can mine the zeolite, put it into these containers, and those containers of zeolite can be used to separate oxygen from the atmosphere, where it can be fed into these power plants that use, like biomass or coal or oil or whatever it is that these power plants use to create electricity. The combustion can be, the efficiency of the combustion can be improved with an increase in the amount of oxygen. And the great thing about these oxygen things is that we can use renewable power, like the windmills and the solar power plants, everything. And what we can do is, while the sun is shining and the wind is blowing, which is irregular, we can make oxygen. And whenever the sun isn't shining and the wind isn't blowing, we will have the oxygen, and we can feed the oxygen into the power plant, and we will just renew our oxygen supply every time the sun is shining or the wind is blowing. Okay, so we will use the renewable power supplies, the solar and the wind, in order to create the oxygen that improves the burn, the fuel efficiency of the biomass, coal, oil burning power plant. Okay, so and like I said, nuclear power is great, but there is not enough uranium on the planet in order to provide everybody with the electricity that they will need. We will need coal and oil and fossil fuel power plants in the future, going into the future. It's a necessity. Okay, so this is the technology track number 2, advanced air separation combustion optimization. Okay, so the problem is combustion systems often waste fuel and produce emissions. Fuel waste, high emissions, low efficiency, inconsistent performance, and equipment wear and downtime. Okay, so this all costs money. The solution is use zeolite-based systems to separate oxygen from the air. And I explained that zeolite-based oxygen separation, that's how it works. You've got, the high pressure goes in, the zeolite removes the nitrogen, leaves the oxygen goes out, you get oxygen, and you can feed that into your thing there. And why zeolite? And you can see that's the way, at a microscopic level, that's the way zeolite looks. It's porous. And when the nitrogen diffuses into the zeolite, this is a type of diffusion that's called interstitial. I believe it's called interstitial diffusion. It's where basically you've got atoms, and there are certain atoms that are too big to get into the porous area, but you have other atoms that are small enough they can get into the porous area. Well, apparently the nitrogen molecule is smaller than the oxygen molecule, and it can actually get in there somehow, while the oxygen can't. That's why it absorbs nitrogen and it doesn't absorb oxygen. It is the interstitial diffusion effect. I don't know that for certain. I'll find out though. or maybe I won't. It absorbs nitrogen, it doesn't absorb oxygen. That's all we got to know. And that's how it provides oxygen from air. Cleaner oxygen, smarter combustion, and stronger results. PSA technology, pressure swing adsorption. Pressure swing adsorption. Okay, that's the kind of diffusion it is. The nitrogen is adsorbed into the zeolite, what do we call it, matrix, the zeolite matrix. Adsorption, not interstitial diffusion, but adsorption, okay? So there you go. Uses specialized adsorbent materials, zeolite, that selectively capture nitrogen from compressed air, allowing high purity oxygen to pass through, okay? And so this is how the whole thing is done: pressurization, adsorption, depressurization, purge, and repressurize. Okay, and that's how those little breathing devices work too. Produces oxygen-enriched air for industrial use. The technology delivers a reliable stream of oxygen-enriched air tailored for high-efficiency, cleaner, and more productive industrial operations. The key benefits: higher efficiency, lower emissions, cost savings, reliable and safe, and scalable solution. So basically, this is something that could work at the small scale and work much, much better at a large scale. The applications: the O2 inject oxygen into combustion systems. And here we have, this is what I'm talking about here. We will take the oxygen and inject it directly into the combustion chamber, where it will make a much more efficient burn. The whatever we're burning will burn much hotter, much more efficiently, so it will require less fuel. So, I mean, on a regular power plant, if you just got a regular power plant, and let's say your power plant is using, I don't know, 10,000 pounds of coal every day. Every day it uses 10,000 pounds of coal. Well, you could take that down to 5,000 pounds of coal, and it'll have the same amount of electrical outlet with the zeolite oxygen production system here. And what that'll do is that'll allow the same amount of coal to have twice the power production, and that's going to cut down with the emissions. It's going to reduce it will reduce the world's footprint, carbon footprint. You see, because the power plants, the things that we make in Oregon that are going to help in America, the hundreds and hundreds, and I believe, I don't know for certain how many coal-fired power plants there are in the United States, coal, biomass, oil, but there's a lot. Okay, there's enough that if we build these zeolite air compressors, we could sell them all over America and all over the planet, because everybody all over the planet uses coal-fired power plants. And this will double the efficiency of the coal-fired power plants, and it will reduce the world's carbon footprint. Our collective carbon footprint of mankind will be cut in half, will be reduced, at least half, maybe even go to a third, depending on how effectively we use this technology. So, and it starts with us in Oregon mining this zeolite so that it can be used in these injection systems. That's good stuff right there. Okay, so combustion improvement, like I said, it's going to improve the rate of combustion. We're going to inject the oxygen before improvement and after improvement. You can see that's just a picture, a little drawing. But yeah, the impact will be higher efficiency, lower emissions, lower costs, improved reliability, and the performance gains will be 5 to 20%, 10 to 50%, and so we will have a better, more efficient way to create power in America and all around the world. The emissions reductions, lower level of carbon monoxide and particulates, very, very important thing there. Fuel flexibility, so it's applicable to coal, biomass, and waste to energy. And one of the important things about Oregon is we have an extensive use of biomass power plants. And what that means is these lumberjacks go out, they cut down a whole bunch of trees, they take it to the chipping mill, and those trees are turned into sawdust, and that sawdust is used in power plants. So we in Oregon, we've got the most beautiful forests in the world. These beautiful, beautiful forests that have been around for hundreds and thousands of years are being cut down systematically so that we can power our appliances. And that cannot last. Because, I mean, the forest, we are replanting the forests, but it takes a lot longer for the forests to regrow than, I mean, we keep cutting them down and we replant them, but we cut down more than we replant. I mean, we're trying to keep up with it, but with more people moving to Oregon, we're going to need a more efficient method of biomass utilization in our power plants. Okay, so you know, there's that. That's kind of an important thing to understand is that, you know, we're basically running out of forest. Okay, we will run out of forest. And if we have more people than we have already in Oregon, we're going to run out of forest a lot faster. The more people we have, the more electricity we need, the more biomass we burn, we're going to need more forest. So this is going to help us to not cut down all of the trees in Oregon in order for us to get the electricity that we need. Okay, so. Important consideration, oxygen production requires energy, and this is what I said, we can use our renewable energy sources like solar and wind in order to make the oxygen, and once we've made that oxygen, when the sun's shining or when the wind is blowing, that's where we can use the oxygen to improve the efficiency of the power plants, okay? An optimized approach, use targeted oxygen enrichment, not full replacement of air. Industrial integration applicable across multiple sectors, proven benefits for broad application, change power, higher efficiency, a stronger process, lower emissions, hotter, cleaner, more productive. It's consistent, equal, lower energy use. Consistent quality, lower energy use, safer operations, better performance, faster drying, lower emissions. And so basically just oxygen is a wonderful thing that can potentially help America to realize a higher fuel efficiency in its electrical production. Okay, so this is a Northwest opportunity. Like I said, zeolite resources and manufacturing potential in the Pacific Northwest. We have zeolite. Zeolite is a very important part of this, and by providing that zeolite and creating the equipment around the zeolite, we can develop, we can design, we can manufacture this equipment here in Oregon, and we can ship it all over the world. And so that's kind of an important thing is our, you know, being able to do that, and this is jobs for Oregon. Okay, it's jobs for Oregon. It's helping Oregon to reduce its use of biomass, and by saving the coal. Okay, remember, we're going to save the coal. We're going to put out all the coal fires. Once we put out all the coal fires, we're going to have all that coal and we're going to be using it at a more sustainable level. So we're only going to be using like half the coal, and so because we're in America, we're only using half the coal that we need. We can still keep extracting the coal from the ground, and we can sell it all around the world. Okay, so that's going to make more jobs for people all over America, higher demand for coal because the efficiency of these coal-fired power plants is going to increase. More people are going to use coal-fired power plants, and because more people use it, the demand for coal is going to increase. So there you have it. It's a good thing. It's a wonderful thing all the way around. Okay. Job creation, building local workforce and economic growth. That's what I was just talking about. Mining, material processing, manufacturing, and stronger communities with brighter futures with local employment, economic multiplier, workforce development, and sustainable growth. The combined system is fire control plus the combustion optimization is going to equal integrated energy strategy. And this is part of the preamble to the Constitution that says, secure the blessings of liberty to ourselves and our posterity. We are taking care of the people who are going to be here in 100 years. That's what we're doing. So, the fire control plus the combustion optimization is equal to a combined system that's going to, it's going to be resilient, it's going to be cleaner, it's going to be reliable, and economic and workforce growth. So it's, like it says down there, synergy in action. So like I said, the good thing. System synergy is stronger together, greater impact. The two technologies, one shared mission. The national impact, it's going to create a new engineering domain, subsurface thermal and combustion systems. International opportunity, we can export the technology to countries with similar challenges. Coal fires exist worldwide and require solutions, so the technology that we develop in America to put out these coal mine fires can be utilized and rented out to other countries. U.S. leadership, we lead today, power tomorrow. It's what we do, we're America. National security, economic leadership, and global impact. U.S. strengths global advantage, innovation, resources, talent, industry capacity, and strong alliances. So, America. So the economic model here is sustainable investment, shared prosperity, and global impact, which is, all a wonderful thing. The three pillars, one mission. So the three pillars are international partnerships, federal investment, and private participation. So the pilot program will start small, prove results, and then scale impact. Measurable outcomes, we measure, we improve, we deliver lasting value. Lasting value. Cost efficiency, job creation, and resource recovery. Long-term vision here is a cleaner future, a stronger economy, a healthier planet, a sustainable energy that reduces waste, creates jobs, and preserves resources. So the closing statement here is this initiative transforms the national challenge into an opportunity, creating jobs today while securing resources for future generations, energy security, good jobs, economic growth, resource stewardship, strong partnership, and a better future. And that's my raccoon of ended presentations. Good looking guy. He might be a rabbit. I don't know. He's kind of growling at me. I don't like raccoons. Anyways, these are my top 10 objectives. Remove $5 trillion from national debt. Propose 28th Amendment for transparency and financial incentives. Secure America's digital infrastructure by requiring PLCs be built domestically. Tuberculosis and polio screening for all migrants as well as food workers, 5-pillar blueprint for empowered local governments, protecting our law enforcement for the Reasonable Operation Space Act, because I don't like when these hippies get right up next to the faces of law enforcement and yell at them and say, ha ha, there's nothing you can do about it. I want our law enforcement to be able to do something about it. I want to require early measles vaccination, American Talent First Act to ensure American workers will prioritize for American jobs, research into immunotherapy for curing cancer, and in-person voting. I support Donald Trump for the Nobel Peace Prize. I think he's a great man. I think he's a great leader. I think he deserves that. And Tulsi Gabbard for president in 2028. Support that. Make America great again. Yes, I support that. But Mosk Dagta, make Oregon's 6th congressional district America's greatest congressional district. That is the big thing that I support. And, well, that is all I got for you guys. And I appreciate you listening to me, and I hope you vote for me. So take care. Thank you very much, and God bless.